Finding GCF and LCM. With the learning target, find the GCF and LCM of 2 to 3 numbers using different methods. Why do we need to study greatest common factor or GCF and least common factor or LCM? Of course, to perform operations involving fractions. Now you have already learned about factors and multiples in our previous lesson. Let's go to a common factor. A common factor of 2 or more number is the factor that is common to the numbers. Example number 1. Factors of 24. You have 1, 2, 3, 4, 6, 8, 12, 24. Factors of 18. 1, 2, 3, 6, 9, 18. The common factors of 24 and 18 are 1, 2, 3, and 6. Now let us get the greatest common factor or the GCF of 24 and 18. And that is 6. Let us go to a common multiple. A common multiple of 2 or more numbers is a multiple that is common to the numbers. Example number 2. Multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 40, 44, and so on. Multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48, 54, and so on. Now, what is the common multiples of 4 and 6? You have 12, 24, and 48. The least common multiple or LCM of 4 and 6 is 12. How did we find the greatest common factor or the GCF and the least common multiple or the LCM of 2 or more numbers? That's right, by using the listing method. We list all the factors and all the multiples, and then we get the common factors and then the common multiples and get the greatest and the least. Notice in example number 2 that if we list the common multiples of 2 or more numbers in ascending order, when we say ascending, that's from least to greatest, then the first number in the list is LCM or least common multiple. Aside from using the listing method, we can also use the prime factorization method to get the GCF of 2 or more numbers. Let's have this example. Find the GCF of 24 and 18. Step 1. Get the prime factorization of 24 and 18. We have 24 is equal to 2 times 2 times 2 times 3. 18 is equal to 2 times 3 times 3. Step 2. Mark all their common factor and multiply them. The common factors are 2 and 3. That is 2 times 3 equals 6. And 6 is the GCF. We can use another method to get the GCF of two or more numbers, the Euclidean algorithm. This method requires successive division. First, you have to divide the larger number by the lesser number. Dividing yields a quotient and remainder. Example: find the GCF of 30 and 46 using the Euclidean algorithm. Step 1. Divide 46 by 30. As said earlier, you have to divide the larger number by the lesser number. That is, 46 divided by 30 equals 1. Remainder 16. That is 46 is equal to 1 times 30 plus 16. Step 2. Divide the last divisor by the remainder. 30 divided by 16 equals 1. Remainder 14. That is 30 equals 1 times 16 plus 14. Step 3. Divide the last divisor by the remainder. The last divisor is 16 and the remainder is 14. That is 16 divided by 14 equals 1. Remainder 2. That is 16 is equal to 1 times 14 plus 2. Step 4. Divide the last divisor by the remainder. The last divisor is 14 and the remainder is 2. That is, 14 divided by 2 equals 7. Remainder 0. That is, 14 is equal to 7 times 2 plus 0. Step 5. Since the remainder is 0 and step 4, the GCF is the remainder in step 3. Thus, the GCF of 30 and 46 is 2. Least common multiple. We can also use the prime factorization method to get the LCM of two or more numbers. Example: find the LCM of 4 and 6. Step 1. Get the prime factorization of 4 and 6. That is, 4 is equal to 2 times 2. And 6 is equal to 2 times 3. Step 2. Multiply their common factors. 2 by the remaining prime factors 2 and 3. That is 2 times 2 times 3 equals 12. And 12 is the LCM. Another example using the prime factorization method in getting the LCM. Find the LCM of 8, 6, and 12. Step 1. Get the prime factorization of 8, 6, and 12. You have 8 is equal to 2 times 2 times 2. 6 is equal to 2 times 3. 12 is equal to 2 times 2 times 3. 2. First, find the common factor of the three numbers. That is 2. Common to these three numbers is 2. Next, multiply the result by the remaining prime factors. So the remaining prime factors here, class, are 2, 2, and 3. This 2 with a partner is counted as 1, and 3 with a partner is also counted as 1. That's why we have the LCM as 2 times 2 times 3 times 2 equals 24. The common factor is 2. The product of the remaining prime factor is 2 times 2 times 3, or 12. Hence, the LCM is 2 times 12, or 24, because we multiply the common factor to the remaining prime factors. Are the different methods you have learned in this lesson. You have the listing method to get the GCF and the LCM. Another is the prime factorization method to get the GCF and the LCM. And the Euclidean algorithm in getting the GCF. Now there are still many methods or techniques in getting the GCF and the LCM. For more examples, you may refer to your math book. And of course, don't forget to do the exercises provided. Remember, the GCF of a set numbers is the greatest divisor of the numbers in the set. The LCM of a set of numbers is the least dividend for the numbers in the set. We are done for today. Please like, share, and subscribe to watch more videos. This is Teacher Jhaniz saying thank you for watching.